In this week's video, we're going to be doing LeetCode challenge number 455, that is assign cookies. That's an easy problem, and let's read the description. It says, assume you're an awesome parent and you want to give your children some cookies, but you should give each child at most one cookie. Each child I has a greed factor g of I, which is the minimum size of a cookie that the child will be content with. And each cookie j has a size s of j. If s of j is greater or equal to g of I, we can assign the cookie j to the child I, and the child I will be content. Your goal is to maximize the number of your content children and output the maximum number. Right, so here we're given two arrays. One is called G, and that's going to be an array containing the level of greed of each child. So each child has, for example, here in this example, child 1 has greed level 1, child 2 has greed level 2, and this one has greed level 3. And the array S we're also given, that's the size of each cookie. So here in this example, cookie 1 has size 1, and cookie number 2 here has size 1 as well. And it's saying that a child will be content, she'll be happy if she gets a cookie that matches her greed level or exceeds it, right? So if it's at least the same size as her greed, then she will be happy. And the goal is for us to maximize the number of happy children. So we need to make sure that to maximize the number of cookies that are given to the children that match their greed level, right? So here, for example, we have cookie size number 1 and 1. We have two cookies, both of size 1. But you see here that we can only satisfy the first child because she's the only one that has greed level 1. This child has greed level 2, so she wouldn't be satisfied with any of the cookies. And the same for this child here, which has greed level 3. And so the output's 1 because there's only one child we can satisfy here with the cookies of size 1. In example number 2, we have two children here. The first one has greed level 1, the second one has greed level 2. And we have 3 cookies of size 1, 2, and 3. And you see now that if we give this cookie here to the first child and the second cookie to the second child, they will both be satisfied because the size will match the greed. They're equal or greater to the greed. However, this cookie here at the end, we don't give it to anyone, but all the children here are satisfied. So that's why we give it 2. That's the number of children that were happy, right? So to solve this problem here, I'm going to be using a 2-pointer technique where I'm going to have one pointer that's pointing to the first list, which is the greed level, and another pointer that's pointing to the size array. Both pointers are going to start at 0, and we're going to be moving through those arrays with some logic, right? And the first thing I like to do here, if you think about it, we can sort both of these arrays. And what that does is that we make sure that whenever we're incrementing pointers, we're moving to higher levels of greed as well as to bigger cookies, right? So the first thing that I'm gonna do here is to sort those arrays. So let me call it sorted G. That's gonna be equal to sorted G, and sorted S, it's gonna be equal to sorted S here. So sorted G, that's the greed level sorted, and S, that's the size of each cookie also sorted, right? And we're gonna be initializing here our pointers, so pointer 1 and pointer 2, and also a variable for holding our answer. Those are gonna be set to 0. All right, so both pointers start at the beginning of the array. They're 0 at first, so while P1 is less than the length of that's going to point to G, for example, and the pointer 2 is going to be pointing to our size array. Okay, so now we need to think, right? So we're going to be pointing to both a cookie size as well as a greed level. And what happens if the cookie is equal or greater than the greed level, right? If that's the case, then the child will be content, so we can automatically increment our answer by 1. And we can then move both pointers because we can move on to the next child and to the next cookie because the cookie was already given to the previous child, right? So we can do here if if the size of the cookie, and that's being pointed by pointer 2, right? If our cookie size is greater or equal than the grid level of the child, which is being pointed to by pointer 1, if that's the case, we want to increment our answer by 1 and then move both pointers 1 by 1, right? So p1 plus or equal to 1 and p2 plus or equal to 1 as well. So we've given the cookie to one of the children. She's happy, we increment the answer, and we move on to the next child as well as the next cookie. If that's not true, right, if this scenario here is not true, the only thing that's left is whether our cookie size is smaller than the grid level. If it's smaller than the grid level, we for sure do not increment the answer, right? But we need to look for a bigger cookie, right? Because the child has a grid level that's bigger than the current cookie, so we just need to look for a bigger cookie. And because here the cookie is being pointed to by pointer p2, we simply increment pointer 2 by 1. And that should already do it. Let's here then return our answer and see if this works over here. Yeah, so this works, right? And as far as time complexity, that would be n log of n, and that's because we're sorting the array, right? And whenever we sort an array, we have complexity n times log of n. And of course here we are going through the array once, so over here we have complexity of n, O of n, but because here we have a n times log of n, the total complexity of this solution is n log of n. We can check here in the LeetCode tool, but yeah, it says complexity n log of n. Yeah, but that was the challenge for today's video, and thank you for watching.